Alright, so for Unit 2, one of the two major things that students struggle with is the atomic chart. Essentially figuring out how to determine the number of protons, the number of neutrons, the number of electrons, if I happen to give you the ion isotope notation, or an atomic number, or a symbol, or the actual isotope name itself. Okay? So our goal is going to be kind of filling in this chart together. If you want a full out answer key on this, this is the extra help sheet with an answer key, so you could actually go ahead and play along at home. How are you doing, dear? No, you're okay. I'm going to be So a real quick overview in terms of what we're actually doing would be, what do each of these columns represent? I guess the most important thing that we have here is the atomic number and the number of protons. And if you've been paying attention at all in class, if we happen to look at those things, your atomic number is simply going to be the whole number that happens to be on any given box in the periodic table. If we're talking about silver, it's 47. If we're talking about nitrogen, it's 7. If we're talking about bromine, it's 35. It is easily the most important feature on the periodic table in terms of each individual box. And that number is always going to be equal to the number of protons. So my 13 here always has to be 13 here. In terms of other numbers on here, we know that the atomic number and the number of protons are going to be equal. Your number of neutrons is going to account for the other half of what's, and I say half loosely, the other part of what's in the nucleus, and otherwise known as your mass. So your neutrons are simply going to be your mass minus the protons, because the mass number is basically what's in the nucleus. So when we're figuring out the neutrons, basically I've told you what's in the nucleus and one other set of particles in the nucleus. Your neutrons are the other set. And then the last thing is basically in terms of electrons. Electrons are basically going through and balancing out with protons, being that protons are positive and electrons are negative. We generally go through and balance those out unless there happens to be a charge. So if I tell you that there's a charge in this column, or this column, specifically right here in the top right hand corner, then you need to go through and account for the number of electrons. If it's got a negative charge, it's got more negative things, more electrons. If it's got a positive charge, like we see down here with this potassium real quick, this positive charge happens to mean there's more positive things, more protons. So with all that being said, I think going through at least a couple rows real quick would probably be very, very beneficial. So let's start kicking out some of these answers. In terms of iodine 125, the major thing that I've been told real quick, obviously I know that this is iodine, but the 125 is telling me a very specific isotope. That is my mass number. So I've got 125 things in the nucleus. I know being iodine, it also happens to, if I go through and look at my periodic table, iodine happens to be, and we'll get rid of that thing, iodine's going to be 53. So I know that 53 is going to be my atomic number and my number of protons. Okay. So from there, to find my neutrons, I'm basically taking 125 minus 53, essentially all of the things in the nucleus, and then the protons that are in the nucleus, to give us, what do we got there, 50, 75, 72. So 72 neutrons. Okay. From there, I've got a couple options. I can go symbol, but the symbol tells me real quick that I'm going to use a charge, and I don't know what that is yet. For the ion isotope notation, I don't know what my charge is yet. So essentially, both clues are pointing to I need to figure out what charge we have. So in order to do that, I'm going to compare my electrons to my protons. I have one more electron than I have protons, which means I have one more negative thing, which means I have a negative 1, and being that it's negatively charged, an anion. Okay? So from this point, I should be able to fill out all of the charts. I've got iodine. It has a -1 charge. It has a 125 up top. And it happens to have 53 on the bottom. Again, we end up having this 53 from the number of protons go here. We've got the 125 go here. And then our charge ends up from that thing. Okay? And then again, your symbol is simply going to be a quick little repeat of whatever we did for the ion isotope notation. Seem easy enough? Okay, so we're going to skip down one just so that we can kind of go a couple at a time and I can leave writing up there. With our second one, or I guess our third one, we have argon here. Argon itself happens to be, if we look at our periodic table, argon's off to the right. We've got element 18, and that's all I need to look at the periodic table for. So my AR, which we were given the symbol of, has a atomic number of 18. So I know right away argon 18 and the number of protons 18. In terms of my mass, again, it tells me that I'm going to go through and to find the neutrons, 40 minus 18, total mass minus just the protons, equals 22 neutrons. Okay. At this point, we've been told that this happens to be neutral, which is a really, really, really big key for us. Okay. The fact that it's neutral means that I happen to have the same pluses and minuses. So I've got the same number. If I happen to have 18 pluses, I have to have 18 minuses. So I've got 18 negatively charged atoms, negatively charged electrons going through and causing a neutral charge. So at this point, the only thing I need to do is throw on an actual name. We're going to go through and call this argon, specific argon, argon 40, and we're going to use our ion isotope notation. We've got argon. There is no charge, but we do have 40 over the atomic number of 18. Okay. And we will skip down two more to the third one. The fifth one. Okay. Just because, again, like leaving space, and we'll go through and we'll delete it all at once so that we can kind of hit through top 5. Our next set here, we've got the number of protons given to us and the number of neutrons given to us. You should know right away, if I give you protons and neutrons, that's everything that happens to be in the nucleus, which means right now I have given you the mass if you add those two things together. So 28 plus 31 gives us our nice little 59. So I know my mass is 59. Okay? But at this point, I still haven't even figured out what element we're dealing with. So I should go through and take that number 28 for protons, because this guy is really important. I know it's going to be my atomic number. It's the thing that identifies what element we're talking about. So let's go find 28. 28 right here. Nickel. So when we work our way back, I know that this happens to be nickel. Okay? And in terms of the rest of this, I have not given you any indication of charge or number of electrons or an ion isotope, so we're just going to assume this is neutral, no charge, which means our electrons are going to be equal to the protons, 28. I know nickel also had a specific mass of 59. That was really key. Don't forget the mass when I'm giving you an indication that it should be shown above it. I know being neutral that there is no charge with this symbol, as you see above. So this is simply going to be Ni. And that means the only thing left is an ion isotope notation, where we've got a Ni 59 over 28. Okay? So that should be 3 of them. You should have a pretty decent idea of what's going on, I'd like to think. I'm going to erase the screen, and then we'll go through and we'll do these 2, so that you can see all of it, and then we'll call it a day from there. Anyways, after hitting erase, I think my favorite setup here for giving you guys problems is the ion isotope notation. This thing tells me everything that I need to know. I know right away that I've got k plus 1. Awesome. K plus 1. Great. But that plus 1 here within k tells me automatically that I'm dealing with a plus 1. And I know we've got cations, happen to be the positively charged ions, so we've got a cation. Okay. Now, that plus 1 is going to go through and actually compare my number of electrons and my number of protons. Problem is I haven't figured out what either of those are yet, so we'll come back to those. Other things that this symbol tells me. This 19 is the atomic number, so I know 19 goes here right away, and it happens to be the number of protons, 19. I know this 39 is going to be the mass, which is very important, so we've got the 39 here, end up with a mass of 39, and now I could fill out my isotope name with potassium and 39, because we're talking about a very specific isotope of it. So at this point, the only two things that I have left happen to be the neutrons and the number of electrons. Well, we already talked about electrons, so let's hit those real quick. I know being plus 1, I have one more positive thing than I have negative things. I know I can't change the number of protons, which means I need to start off thinking 19, but I have one less negative thing. So I'm actually going to have 18 electrons. Okay. And that means the only thing that we've got left is figuring out the number of neutrons, and from there this is simply mass minus pro. Our mass is 39 minus 19, and that's going to give us a nice round 20. Okay. So again, really like the ion isotope notation. If you can go through and solve these charts using that, you are in a great place. And I guess our final setup is going to be this second one that we skipped. Okay. Right now I've given you the atomic number, which you should automatically, red flag should go off and say that thing is equal to number of protons, 15. And I've given you the number of neutrons. And again, right away, if I give you protons and neutrons, your first thought needs to be nucleus. And if we're talking about the nucleus, that's simply going to be the mass. So we're talking 31. So we'll take a quick side trip here. If we're dealing with atomic number 15, we know that we flip to our periodic table, and that's going to be P, which is phosphorus. So I know I've got phosphorus, and again with the mass, 31. I know my symbol, I'm not going to put the symbol yet, I know that's going to be a P, but I need to figure out what's going on with the charge. But wait, no electrons, no charge, no on isotope notation given, so I know that my charge is going to be neutral, so I feel at this point I'm safe just putting a P with no charge. Knowing that there's no charge, I know my electrons have to be equal to my protons. And if my protons were 15, that's going to be a nice little 15 here, which means I know this is neutral. And then my whole setup is phosphorus 31 over 15 in terms of my ion isotope notation. Okay. Again, I hope this was useful for you. At this point, you should really have an indication of the things that are starting to become very related. Again, protons and neutrons, if I got both of those together, it's simply going to tell me my mass. I know that my atomic number is always going to be equal to my protons, and that if I want to figure out my charge and my electrons, those are going to be three of them kind of related to each other in terms of how do they relate to the protons. If I have a positive charge, I have more protons. If I have a negative charge, I have more electrons. Anyways, check back in, give those some practice, double check with your teacher, but you should have a great understanding of how to set these up and what encompasses the inner workings of an atom by the time you... Nope, didn't want to do